Hi everyone, I'm Joey Pickard, German audio engineer and guitar player, and today we're gonna find out how much output power the PRS MT15 head really has. 15 means 15 watts according to the data sheets, but this amp is brutally loud for 15 watts. I've played several other Lunchbox amps in this kind of wattage setting, so orange amps or Mr. Boogie amps, the Transatlantic 15 for example, but with this amps there comes a new style of power amplification setup, I would call it. So low wattage, but still they use 6L6 tubes for output power. They got the colors so many players love, the American sound of power amplifiers. So this could be a reason for why they sound louder than other amps with, for example, EL84 tube amps. But I think there's more power out of this amp than the PRS company is telling us. So let's find out. I'm using, because this amp has two channels with no master volume, a noblesse switcher only as a volume potty, because I'm putting a sine wave directly into the effect loop's return. So I'm going directly around the complete preamp and just into the power amp section. And if I hadn't choose the little volume potty, it would blast my ears immediately. Blast my ears is the next point. I didn't have connected a cap. I connected a resistor with 15 ohms. I don't have 16 ohms, 100 watts, 15 ohms here. And I played through the dummy load. So the next thing I do is I record the oscilloscope, the input signal that I'm sending and the output signal that I'm receiving, and we're going to watch that sine wave and how it looks, and depending on where the end of the sine wave maximum from that amplifier is, we're gonna find out how much powerage it can handle, it can put out. So the whole setup is, I'm sending a sine wave, I'm sending a 82 Hertz signal, so this is comparable like with the E string of the lower E string of our instruments, and it's coming directly from my Focusrite Scarlett 18i6 out into the switcher, where I just use the volume knob. Then I'm putting it into the return part of the PRS 15 effect section, and then I'm getting out of the tubes into my resistor, and then I see the signal. I also take the signal back into my computer and analyze it with a freeware software called ARTA for non-commercial use. Let's have a quick look at the measurement setup. I'm using a software signal generator in the software ARTA. I'm producing 82.6 Hertz. That's equal to our lower E string on the guitar, but it's a clean sine wave without coloration or something. Then I put it out from my audio interface into a volume control unit. That's the knobless switcher you saw previously. And then we put it into the FX return of the PRS MT15. We have no master volume controls, so this is the only way to adjust the sine amplitude for me. Then I also put that signal into the channel 1 of my oscilloscope to measure and see how much output I generate. At the output of the MT15, I'm using the 16 ohm output and put it onto a dummy load of 15 ohms. I don't have a 16 ohm load, but speakers also have a wide variety of different resistances at different frequencies, so it shouldn't be that big point. I'm putting that output signal onto channel 2 on my oscilloscope, and I get it back into my software via the audio interface to analyze that spectrum and harmonic distortions. Okay, now let's do this. ARTA is running, my measurement software. The PRS is now running, and the oscilloscope is also running, so we can start. I'm sending out the signal right now. There it is coming. The lower sine wave is the input and the upper sine wave is the output. And now I show it on the oscilloscope what we are searching for. We can see here the top and the bottom of the sine wave, and my oscilloscope is on channel 2 configured to 10 volts per division. So this is what we're seeing is 10 volts per division for the second channel. So this amp is putting out now peak to peak 20 volts on 15 ohms. Now I drive up the volume further and further. Now we are at 20 volts peak to peak. And now it is getting interesting because the sine wave doesn't look like a sine wave should look, because this is the first reaction of the tube power amp. It's a distortion. We can later see it on the computer, on the ARTA software, how much we are now at 6.8 total harmonic distortion. And I'm going further and further. Further, we are at 26, maybe 27 volts, and there is what we're looking for. This top. This is the power amplifier maximum output voltage, and this is here at 10 volts each, so 2, 4, 6, I would say 6 or 7, 27 volts on 15 kilo ohms. Okay, and we are at 7.8 total harmonic distortion. So I'll turn it down, and now we have to calculate how much that power is. It's pretty easy because we just have to perform Ohm's law, and that's done with the old school way. So we have our resistance, 15 ohms. Then we have our output power, that's peak to peak, U peak to peak. It's 27, it's just peak. Peak to peak would be 27 multiplied with 2, so it's just peak. 27 volts. So now we need to perform one thing, because we want to get the root main square power. So the normally power is rated by this ratio, because it's a value that is comparable, and this is it's too short to explain it completely here, but we need to compare it with an comparable DC signal. So we need the value, the ratio of a square to the ratio of a sine wave, and that ratio is 1 divided by root of 2 multiplied with our peak voltage, and that is U root main square. And now we're putting that together in the formula for power. It's normally P is voltage multiplied by current, but we don't have measured the current. We have a fixed resistor, so we're putting U squared, so voltage squared, to the resistance. So that is, well, first we have to calculate how much 27 volts is. 27 multiplied with, I'm doing a bit of rounding here, 0.707. That's the factor 1 divided by square root of 2. So that is giving me 19.089 volts. Now I multiply it with, where do we have it? The same value, because we need to square it. Okay, so I'm getting 346.3899 to 1. Now I divide it through my resistance, 15 ohms, and I'm getting 24.29 watts. And that's it. 24.299 watts. So of course it's measured with a bit of distortion. At least we had around about 7% of total harmonic distortions. But we are guitarists. I like to play metal music, and even if you play jazz or something smooth, every guitarist wants to have that kind of coloring from the tube, and the power amp is, before it gets into the clipping mode, the top end of the sine wave, it's deforming the sine wave like a tube amplifier does if it's not totally designed for being absolutely straightforward, non-distorting. But this is wanted, so it's okay. We have 7% THD with this measurement, and that's it. I would say this is not really the absolute accurate way to find out, but it's okay. So if I say this amplifier's got 22 watts, I won't be wrong. And even if we are going back to 15 watts, so you can calculate this backwards and watch which voltage would be at 15 watts. I'm totally sure that we won't getting under 1% THD at all, because this is a tube amplifier, and at this power, I saw it, it is performing much more THD, so we can't comply to audio standards for interfaces or like this. It's a music instrument, and that's it. So the MT15 has much more power than we think, and I'm happy to know that now. Bye.